All right, hello everybody. I got James Croton and Jason Baker on the phone with me. And Jason Baker is with Baker Property Inspections. And Jason, if you don't mind, oops, I'm sorry. Let's get these guys on here. Go ahead and introduce yourself.
Hello, everyone. Just here with Baker Property Inspections, looking at hydronic heat today with Charles and James. Been serving Southwest Michigan for a while. Look forward to answering any questions you might have.
And James.
Hi, I'm James Carlin with Up Close Home Inspections here in Lorain, Ohio. And I'm here with Charles to talk about hydronic systems and to learn more about it.
Outstanding. So we're going to get started, and these guys are going to jump in a little bit as we go along. And if there's any questions, please just type them into the chat box there, and we're going to see it, and we'll answer whatever we can answer, and we'll shrug our shoulders on the things that we don't know. Plain and simple. So the first thing we wanted to talk about was you're going to run into different types of boilers or hydronic heating systems when we come into it. We're going to focus on this older unit here for the most part, but I just wanted to make it clear that it doesn't matter if it's an old gas burner such as this one here, or if it's going to be the newer high efficiency water heaters that they're using to create hot water. Anything is going to be fine, and we were kind of chatting a little bit beforehand, and this was just a cool picture I got off the InterNACHI education site. And this one here is an old boiler from a Hydronic, an open hydronic heating system. And it's kind of cool because you'll notice there's no pumps on there, there's no pressure relief valve, there's no expansion tanks, because there's actually an open pipe that goes up and out through the roof. And if the water starts to boil or get too much, well, the water just spews out of there. So we're not worried about exploding or anything like that. Now, James and Jason, or more, first James, you said you don't have a lot of hydronic heat in your area. Is that true?
Correct. The homes around here mostly natural gas furnaces and hot water tanks. So I haven't seen it yet. But I'm not. I'm sure it might be some in the older homes or so.
Without a doubt. What about by you, James? Or Jason, I'm sorry. What about by you?
Sure. I would say it's mostly in older homes, except for newer homes that have the slab heat hydronic systems. Um, it's really pretty rare, honestly. Less common. I would say 5% of homes at the most. When I'm really rolling through them.
Yeah, I think that's fair.
And mostly it's hydronic as well. The number of steam systems I see, I've probably only seen about 4 or 5 steam systems myself.
Cool. What I like about these things is, as far as I'm concerned, they're pretty simple. They last for a long time. I think this thing is like about 30, 40 years old, if not more. Um, and the only thing that really goes bad on them are some of the valves or the pump itself. So I do my best to try and educate our clients how they work, what the different parts are, and to get them prepared as much as possible. All right. But they all have basically the same components. And I think I want to break down those components to the beginning and where stuff comes in. So the first stuff, and James, I want to ask you this. What's your typical water pressure on your city houses by you?
Sure, good question. The water pressure here in this area is between 60 and 80 psi.
Oh, that's pretty high. Yeah, we're like
Yeah.
around 40 and 60, with 50 being our average. And then if you're in the city of Chicago, that's actually going to be around 20, to 30. So sometimes
Right.
they actually need a booster to get enough pressure to get the water up in there. So sometimes we'll see pumps on these. And But anyway, so the water, as it comes in, this pipe right here goes to our main water feed. And James, you said between 60 and 80, right?
Correct. Yeah, the highest I've seen was around 8, but mostly around like I would say maybe 60, 65, but highest, I've seen up to 80.
And I know once we get over 80 psi, then the valves on like washing machines, dishwashers, things like that, they're not going to work. So we're going to have some sort of a pressure reducing device. But since boilers themselves operate at 30 psi, we need something that's going to bring that pressure down. And that's what this guy is right here. So I'm going to go ahead and zoom in on him. And this is called a pressure reducing valve. And Jason, I'm going to give you a little test question here. Do you happen to know what that holder is for?
Well, it appears to be missing the lever for the quick fill or bypass on the pressure reducing valve.
Dude, you're awesome. So I'm going to skip up a slide real quick, then I'm going to come back to this thing. But this is what he's talking about, the fast fill, this lever right in here. So let me go back to our original one. And then, James, what's this screw up here for?
Oh, it's a brown blank. Just to reduce the pressure or increase the pressure in the home.
Exactly. So these things will go up to 30. You could probably get it over 30 psi as well. Something else that's on here, we do have an isolation valve. You could actually see the ball joint or whatever on the back end of it for the lever. And this will shut all the water off to the heating unit itself. But the tighter we make this screw up here, the higher the pressure. And depending on how tall the building is, we have to tighten up that screw so we can push the water all the way up to the highest radiator and make sure that we got enough to get up there. One thing that's kind of important, and I really don't think it would work without this, but this little arrow, can you guys see that okay? On there, that arrow on the, that's also a one-way backflow prevention valve. All right. And what that does now is that creates a closed system, because once water gets into the heating side, so it gets past that arrow, everything on this side is closed when it comes in there. So we're going to have pressure relief valves. We're going to have expansion tanks. We're going to need that once we get things that are going to get hotter, the water's going to want to expand, and we need to be able to absorb that with air. Exactly. All right. Pressure relief valves, I'm a big proponent of these things, and I do believe in checking them. And I'm going to throw this out to you guys. What's your 2 cents? Touch them, don't touch them, move them, lift them, leave them alone, or?
Well, I hate to hear the conversation about breaking on testing with these sorts of things. So, at least with water heaters, which is where I typically see a temperature pressure relief valve, I usually just do a visual check. To see if there is corrosion, signs that it has been leaking in the past, and just recommend a service for that.
Fair enough. What about you, James?
Same here, same as Jason. I don't mess with them too much, but if I see a lot of corrosion around it, I recommend for replacement. I did pull one time, and luckily it closed, but I just don't want to be in a situation where I open it and doesn't close back up.
Exactly. Now, I don't...
Go ahead. Personal experience note, I opened mine to test mine because I had failed to do just a regular test on my water heater, and it immediately started... It was nonstop drip afterwards. I neglected that periodic check, and then when I went to check it, it stuck open on me, so I had to go to the hardware store and replace it.
And what we're talking about is lifting this valve and twisting it upwards, and that's going to open it, all right? Let me just get this out there. I am stupid, all right? So I do believe that we should be checking these, even though most people are going to disagree with me. And everybody that listens to me on this one, I need you to make your own decision, all right? Don't just do stuff because we do things a certain way. but we actually twist these. We'll spin them around. And when we start spinning them, they should always move relatively easy. We found that if it's starting to corrode on the inside, then it's going to be real stiff. And what on this particular one, I did that test and I videotaped it. And let me come back to that one. Here it is. And then I'll come back to the water heater one. But this one here, we videotaped what we do. And in the beginning, once I play this video, I want you to notice that it was real stiff. It didn't really want to move. And then I gave it enough pressure and you hear this little click. And then it was moving really easy. So it didn't go. Then it just snapped. And now it's able to go easy. So it's corroded in there. And I was able to break free that corrosion that came in there. Now, I did not lift it. I did not flow any water through it. But that whole spring had everything corroded on there. So when we do this and we get this kind of a look and we videotape them and put them in the report, we're going to encourage our clients to replace that pressure relief valve. And just another test question, because you guys are doing really good. Do either one of you two know how often we're supposed to be replacing these things?
I would say every 3 to 5 years.
Yeah, it's 100%. I tell everyone every 5 years they're supposed to be replaced. All right. So let's go back to the original picture. And for water boilers or hydronic heat, we should memorize a few different numbers. So let's get water heaters. So we're going to go water heater, normal operating pressure, pressure relief valve. All right, so normal operating pressures for standard water systems are going to be anywhere from 20 to 80. Water heater pressure relief valves are going to be set at 150. And then hydronic is going to be less than, points to the lower one, right? So this is less than 30 psi. Once we get to that 30 psi or higher, then the pressure relief valve is going to open up and we're going to spew water on the floor. So we can't be at that pressure. We have to be lower. And then, of course, the PRV is going to be 30. Steam systems, they usually operate between 2 and 6. Now, they have high-pressure steam systems that will operate on higher pressures, but those are going to be for, like, giant apartment buildings or something like that when they're pushing steam to a further distance. But most homes that operate on steam, it's 2 to 6, and they make two different types of valves. One of them is 12 psi and the other one is 15. So either one's acceptable. It's not a range. It's either 12 or 15. So here we have our hydronic pressure relief valve, and we can see right on that tag, and I look for the right tag all the time. This is kind of a big deal to me. And I look for the right tag where it's going to say 30 psi, because this fitting down here is a 3/4 inch fitting. This fitting right up in here is, again, a 3/4 inch fitting. So the water heater pressure relief valves, those are also 3/4 in, 3/4 out. All right. The steam are 3/4 in, 3/4 out. Pool heaters, 3/4 in, 3/4 out. All right. So it's easy to go to Home Depot and buy, let me erase all this, and buy a pressure relief valve that's actually rated at 150 psi. Now that's fine for a water heater, but this creates a big problem for steam heat or hydronic heat. So again, even on the water heaters too, I'm going to give this thing a spin and make sure it's free and clear when it comes to it. But nonetheless, to me, these things are a big deal. We don't open them or flow any water, but we definitely make sure there's no corrosion inside of it, and that's the minor test that we could do. And I haven't had one break on me yet. So now we're looking at the other side of the boiler. And, we have to hook these things up to the thermostats. And it's kind of like a gas furnace if you think about it. The thermostat's going to turn on. It's going to call for heat. And we're going to create the draft. But eventually we're going to get to the point where we light the fire. And the fire is going to start heating up the heat exchanger. And then once that temperature gets hot enough, that's when the blower fan kicks on. We don't want the blower fan to kick on right away because we're just going to be circulating cold air. So we want to make sure we heat the area up first. Same thing with these things. So if I zoom in again a little bit, we got our thermostat wires. And if we follow them down, they go to our boiler control, and that's our on-off switch that comes in there. So when the thermostat calls for heat, the first thing that's going to happen is it's going to hit this transformer, and it's going to light the fire on the inside and start heating up the water. And do you guys know what this thing is called here? An aquastat. Have you ever heard that before?
The aquastat.
Yeah.
All right. So in this one, this
That would be
particular,
the
Go ahead.
temperature sensing device for the water portion of the boiler unit.
absolutely. And then this, when I zoom back out again, you're going to see that this runs right to the pump, or the motor for the pump. And once we get up to enough temperature, then we're going to start circulating the water. All right. And that's all that this thing does. So one, the thermostat's going to turn the boiler on. And then once I get up enough heat, the pump is going to turn on. And once the thermostat is satisfied, everything's going to shut back down again. Have you guys ever seen pumps and fill ports like this?
No.
And Jason, you're saying yes.
No, I haven't.
Yeah, sure. I've seen those sorts of oil ports, servicing ports.
How often do you tell your clients to fill that?
I'm probably not very good on the maintenance of boiler systems, which is one of the reasons why I recommend people have them evaluated.
Gotcha. We tell them once a month that they should at least put it in there. And usually you're going to find a small little oil can that's on top of there. And you just basically drip everything right into that little hole there. And there's a lid that flips up and covers that thing. If you don't and you forget, I have heard these things squeal a few different times. And it gets really loud when they're squealing. And then once you let it go at that for a little bit, then we're going to start seizing our pump. And once we're doing that, now we're going to have to be undoing some bolts and replacing the whole pump once that thing's seized. Most of the problems we're going to get are going to be with the motors themselves. And if somebody's confident enough to switch out a light switch or an outlet, replacing these motors is really not all that difficult. So I do what I can to talk them into having a spare motor sitting there ready to go. Because when they fail, it's always going to be at 2 o'clock on Christmas morning, when you don't have a service guy available and now you're without heat. So, learning how to do that, even if they have to go to the University of YouTube, I'm okay with it. So, and this is just the pump itself. So again, this section here is the actual pump, where this section here is the motor for the pump. And then right in there is that flip top that I was talking about, where we put the oil in there. And we want to look for that as well, or otherwise tell our clients to buy it. So on this one here, we can see our pump down at the bottom, our thermostat wires here, our aquastat coming in here, our transformer that turns the boiler on, and then our water starts circulating through the house. They ended up having problems with the old black iron pipes that they were using for heating, so they tore a lot of those out and replaced everything with copper, which was a little bit of a pain in the butt for us, because now we had to trace everything. It wasn't just, okay, that's the water line and that's a heating line. We had to figure out which was which when it came to it. But, I work with some pretty smart cookies, so they were able to do that pretty easily. Temperatures and pressures, again, as I mentioned before, we're going to want to be. James, what's the question?
Yeah, can you hear me?
I can.
Okay, cool. Hey, so quick question on hydronic boiler systems. Would you, let's say the per customer has a hard water. Now, they don't have city water, they have hard water. Does hard water affect the longevity of a hydronic boiler system?
I'm sure it does. All right. And I'm sure it's going to be
Okay,
building up some sort of calcium or whatever it does inside. But I got to be
right.
completely honest. That part, I am on the ignorant side when it comes to it. So everything that we have
Okay,
here in Chicago is all Lake Michigan water. And pretty much all the
okay.
suburbs, within 20, 30, 40 miles is all Lake Michigan water. So we don't have that sort of stuff.
Yeah,
And once we get out in the boondocks, I really don't see any hydronic heating systems when we get way out there. So I got to
all
guess
right.
at that answer. It's not fair to you. I'm sorry. But I really don't
No,
know.
you're fine.
Yeah. I
I've had
really don't
customers
know when it
have
comes
water
to it.
softener in their house. Yeah.
But I'm just
So,
equating that
yeah.
question
I
to
just
what
have
happens
customers.
with a water heater. All right. And even with
Yeah.
that, I always get confused and mixed up. And I want to do the research on this. But I know on the anode rods, they have magnesium anode rods, and I know they have aluminum anode rods. Most of the ones that we're going to see in our area, I believe, are magnesium. You could tell the difference on the anode rods because there's going to be, well, the anode rod comes down and then there's going to be a bolt on top of it, right? And I keep forgetting which is which,
Right.
but one of them has a little nipple on top of it. So the in our area, all the houses have that nipple, and we look for it. And when it's on a well system, we actually want it to be flat. We don't want it to have that nipple on there. And if you put the wrong one, the anodes usually fail, I want to say within 2 years, 3 years. You'll either get black specks coming out of the hot water or gold or green specks coming out of it. And that's telling you that the anode rod is bad. And once that anode rod is gone, then everything else is all getting chewed up, including the actual boiler tank itself. All right. And these older ones are thick cast iron, so they're going to maybe be able to last through all that. But you get these high efficiency ones, and those are thin heat exchangers in there. And I don't know, I think it actually can damage those things. So, yeah, I would, I got to push that off on somebody who's more familiar with the local area. So. You okay if I go on to the pressures in
Okay.
that?
Thank you.
Oh no, thank you. I like talking about this stuff. I'm too much
Absolutely.
of a nerd. Um, so pressures and temperature. All right, you can see that after 30 psi, we go into red line on these things. So we don't want to ever be over 30 psi. You can run these things all the way up to 29. That's fine. Once we get over that, then the pressure relief valve should open up and release that pressure. Typically, when they're operating, they're going to be operating around 140 degrees. This was the summertime. We just fired up this boiler. I didn't feel like waiting until it got all the way up to 140 degrees. So we were at a little over 100 degrees. And which is fine. We were able to do the test to make sure the pump is working, it's circulating hot water. And then we send one guy throughout the house with the thermal imager, and we're able to take a quick glance at every radiator and make sure it's completely filled with hot water and that there's no air trapped inside of it. So it's pretty cool pictures if you ever run into one. We just shoot it and take some pictures, or if it's hydronic heat in the floor, you could actually see the pathway in the floor. And I don't know, it's kind of that woo woo stuff. I get my clients that get a little nerdy on me when we launched a drone. They're like, oh, that's so cool. Same thing when we show them the thermal imager of all the radiators working. But in my mind, it's like, yeah, I just saved myself a lot of time because I could just zip through the rooms real quick and shoot it with this camera, and I could see if they're working or not. So, but I would remember 140 and 30 psi. Um, Notice the other pump for the hydronic system was red. All right, this is also a water circulating pump, but this one's gold. Do you guys have an idea what this means?
That it is for sanitary supply or yeah, potable. There you go.
For potable water. So this is off on our water heater, and this one is just circulating the hot water so that they don't have to wait for the hot water to get to their area. So red, and we're talking about the pump portion, not the motor, just the pump. All right. So red is no way. We don't want that to touch our drinking water, but the pump, it really doesn't matter so much. Gold is the only thing that's for potable water. All right. So again, there's our red pump. That's not going to be good for drinking water, but it's just fine for heating water. Once the water gets into this section, so it gets past that pressure reducing valve, it's considered wastewater, and we can't let it come back into our drinking water. And this is a little bit further version from the water heater that was right next to it. And what do you guys say about the height off the ground on these pressure relief valves? I don't even know if that is a pressure. That's not. The white one is. Show you how dumb I am. All right.
6 inch, less than 6 inch clearance, or 6 inches or less, but it cannot be capped, cannot be plugged.
Can't be downsized. Can't have threads. Can't have any opportunity to be plugged. In Illinois, this is actually illegal. All of our pressure relief discharge tubes by our Illinois plumbing code, they have to be metallic. So I mean, I don't know what I'm going to tell somebody because they sell these things at Home Depot and everybody's putting them on there. And I don't think the water heater cops are coming to arrest anybody. But, I know that some plumber's going to walk in here 3 weeks later and he's going to say, well, it's going to be $150 to put out a new, temperature pressure relief discharge tube because it's got to be metallic, and your home inspector should have told you that. So send him the bill. He'll pay us. And I'm like, well, thank you. But so we just make a comment of them and let people know, but it's their choice, what these go. Now, do you remember what I said the pressure setting was on this?
150 is standard for the hot water tank.
Now, here's something that not a lot of people know, so I'm not going to be surprised if you don't. What if I'm in a contained vessel, right? The water heater. So boiling temperature is 212 degrees, all right? But I have to allow air to be made. So as long as I keep it in this contained vessel, I can heat that water over 212 degrees, and it will not be able to convert to steam because I'm not going to give it that room to expand. You with me on that?
Correct.
So what temperature do I have to get to before I get to 150 psi? I know it's a curveball.
Are they 275? I'm trying
Close.
to remember.
Yeah, close. It's 300 degrees.
300.
All right. You want to watch a good video?
All right.
Watch Mythbusters water heater explosion. All right. And they bypassed all the safety devices on here, and they just kept heating it up. And I think they got to something like 310 or 314, and that's when the tank ruptured. So this thing here, this pressure relief valve is going to open at 300 degrees. And things have to go wrong. All right, we have to have a lot of planets in alignment for things to go wrong. My flame and my temperature sensing in there has to turn the fire on, and then that has to fail. And that has to be locked in the flame open position. And then it's got to keep cooking and cooking and cooking. And then I got to be blocking my pressure relief valve. I can't let stuff like that release the pressure. And then the tank is going to rupture. And when these things go, when water converts to steam, it actually wants to take up about 1,000 to 1 space. So just picture having 1,000 water heaters in that building instantly. when this thing explodes. So it does level buildings. And when the Mythbusters did that, they sent this thing like a missile, and it just destroyed the little house that in there. So it's really a good movie. But the biggest thing for us to realize is this 300 degrees of heat, when that comes out of the end of there, now it's atmospheric pressure. It's no longer 150 psi. It's atmospheric pressure. It's going to instantly change the steam. And if we didn't have this tube down at the ground here, it's going to blow into somebody's face. And if they inhale that steam at 300 degrees, they're going to burn their lungs. And if you burn your lungs, well, obviously you can't breathe. You can't breathe, you're going to die. And I don't want to get all drastic. These safety features that are built into these things, it's very rare that they go off. I have only seen it once in my lifetime, and that was as a fireman. We had a fire alarm going off at a local florist by us. We get in there, we go to investigate, and sure enough, their water heater the pressure relief valve was opening up and dumping a bunch of steam inside the room, and the whole room was filled up with steam. I kind of recognized from the home inspection stuff what was going on in here. And I just went straight to the gas valve, and we can't really see the shut-off valve here anywhere. But I went straight to the gas valve, and I just turned the gas off to the appliance, and then everything settled down from there, and the problem went away. But, I'm stuttering a little bit here just because I think it's a big deal. And these pressure relief discharge tubes, I can't stress how important they are. Getting them down to the ground is kind of a big deal to me.
They're not a very costly, expensive safety device to maintain, but it's critical that they be maintained because the consequences could be pretty drastic.
I couldn't agree with you more. All right, a little bit further away. So just a little bit of a recap. This is our main water line coming in. This is our isolation valve going there. Then our pressure reducing valve plus our check valve to keep the water from coming in there. This is our pressure relief valve. We got our expansion tank. Typically, I like to knock on these. So when it's cold, I'll just start knocking on that, and that should feel solid or, kind of like a thud because it's filled with water. But then if I tap up high here, that's all air, and I should get a ding when it comes to it. And it should change depending if the water's hot or not. I like checking, make sure I got the right pressure relief valve on there. Everything else, I'm looking for leaks. This device I don't always see on many boilers, and I don't really think they put them on there too much. Sometimes you're going to run into an air separator, but this is called an air trawl. And it's just a valve inside there that if there's water in the system, it's going to allow the water to flow. But if there's air in the system, it's going to basically hold the water into the tank so it doesn't let it come out of there. It has to do with the pressures. And notice we got another aquastat on this side too. All right. So this is going to be our discharge, our pump. Our pump usually goes on the return line, and then we put our supply side is going on here. So we got another aquastat on that one as well. Let's see if we get a closer picture of that. So this is that air trawl that I was talking about. And basically it's just another safety device so that we're not letting air flow or we're not trying to heat air for lack of anything else. Now this boiler, and again, this was a couple weeks ago we did the inspection on. When we fired it up, we always like to take combustion readings as well, and backdrafting is always a big deal to me. And I don't know why I didn't get a picture of this into the system, but if you look where that arrow is down there, you could actually see the case of the whole boiler system is corroded pretty heavily right there. All right. So this was actually backdrafting. I think we had a clog in our chimney somewhere, and nothing was going up and out. Everything was coming down and in. And it was coming in for such a long time that it actually started eating away at the paint, and then it started rusting, and there was a big hole in the cabinet itself. Now, it didn't damage the heat exchanger, but nonetheless, we got a hole in the cabinet because this has been going on for a long period of time. So, kind of a big buck item. They had to go in there. I want to say it was like in the $4,000 to $5,000 range because they had to get the chimney sweeps in there and clean out the venting from the flue inside there. So the sellers weren't too happy at that point in time. It was kind of a big buck item. This is just a picture I took off the InterNACHI slides. And there's different ways to go ahead and zone out the different parts of the house. All right. So most of the time, at least in our area, we're going to find multiple pumps. We don't really have valves with one pump. That's not norm for us. And it gets to be a pain in the butt because you got to run through the whole house, find the different thermostats, turn them on. We do them one at a time. And then we want to check. And those pump motors, they're quiet. You can't hear them running. You got to actually put your hand on it and feel that they're running. And then we go to the next zone and turn on the next pump and just to make sure. I guess you could turn them all on, and as long as they're all pumping, then you just did them all in one shot. But I think every time I do that, hoping for good luck, it always fails. There's always one bad, and then I got to go ahead and do everything over and over again. So I just gave up and do them one at a time. So that's my fun. Radiant panels, I just threw this up there. We might see the PEX tubes in walls. Usually we'll see them in the floors. Sometimes they're in ceilings. I just want to give you a rough idea what they look like. But again, if you know you got them, get that thermal imager out and do what I like to call the glory picture. And people just love it. They go all woo-woo on you. The pipes themselves, you're going to run into black iron, sometimes copper, sometimes galvanized. Sometimes they're painted and not. It's hard to tell what it is. But don't forget your dissimilar metals. All right? And when we start coming in and switching from our copper to galvanized or copper to black iron, or even if I use a metal strap on copper, I got to do something to break the electrolysis on that stuff. And then this goes back to that expansion tank again. We were just talking about when it's cold and when it's warm. So the water's going to want to expand. But we need air in those systems in order to compress because the water isn't going to compress. What happens is that water absorbs the air that's inside those tanks over a period of time. And then they'll just normally fill up. So usually what we need to do is close off that isolation valve and then drain the water out of the tank, close the drain, open up the valve, and then we put air back into the tank and everything works again and works just fine. So that on this one, it's kind of hard to see, but right there is my expansion tank drain. And I'm sorry I can't zoom in on that. And then our isolation valve, I think, is blocked by this view here. All right. And last but not least on the slides, just basically a synopsis of how these things work. All right. In this drawing, they're showing an oil burner down here at the bottom. It's going to heat the water that's inside the tank, and we're still going to call it a heat exchanger. Once that water gets hot, the pump is going to start circulating the hot water. It's going to go to wherever the room is, and then that heat is going to be expelled. And that heat normally rises. So as it rises and cools and comes down, that's what creates these convection loops. We should know those terms, convection loop. Anytime we move heat via air or liquid, it's called moving heat via convection. If we move heat through a solid, then it's conduction. So the heat exchangers are made out of metal. The fire heats up the metal. Metal transfers the heat into the liquid, so that's conduction. The liquid moves around, that's convection. We get our loops. coming in here. So we create our convection loops, and the cold water comes back from the pump, gets reheated, and everything is cool again and just keeps going. So I did not see any questions pop up on here. I don't know if you guys did or if you guys have any questions at all. But that's all the slides that I got the chat on. So you tell me if you got anything to add.
I think that was great. I appreciate your time, Charles.
No, you guys too.
Thank you, Charles. I really appreciate it.
So I'm going to throw out, give these guys a little bit of love, please. So if anybody's listening, please make friends with Jason Baker and James Croton. They're smart, wonderful, kind, helpful. I'm going to go through the whole list when I was a Boy Scout, maybe. Who knows? Courteous, kind, cheerful, thrifty, brave, clean, reverent. I think I got most of them, But you two gentlemen are wonderful people. So throw some likes, look at their pages, give them a thank you. It really means a lot. We're going to keep these videos. We're going to keep doing these once a week. And I hope that they're helpful getting people to understand some of these things in a simple way. And then me too. I appreciate it if you throw a little love my way. So if you go to YouTube and, /C/The Home Inspectors, that's our channel. Or you could do a search for Chicagoland Home Inspectors. Like, subscribe, hit the alert button. You're going to see every week there's going to be a new one coming up there. And same thing with our business. We're trying to kick up our Facebook and Facebook advertising so everything helps. All right. Anything else to add, gentlemen?
Yeah, I have one question for you, Charles.
Yeah.
So have you seen a decline in hydronic heating systems throughout the years? Because I haven't really personally have not seen one yet, which I'm not saying I won't, but I haven't seen any yet, and it's really interesting. I want first of all thank you very much for doing this for us, and it's really informative. But yeah, do you see a decline in hydronic heating systems or upcline? I haven't seen.
On the higher end homes, people like to put them in there. When they got a lot of money to spend and they're big, wide open areas, then I see them getting installed in new construction. Otherwise, it's just so much cheaper and easier to throw ductwork and a gas forced air furnace in there. So I don't really see new construction being put in there unless it's a multi-million-dollar home.
Sure. Okay. Thanks, Charles.
I would concur.
All right, guys, thank you. And I'm going to go ahead and end this. And you're wonderful. And we're going to get back on Mondays. I don't know what the next subject's going to be, but yeah, we're going to do it Monday at 4:30 next week. And again, thank you and goodbye.
Chicago time. Looking forward to it.
Time. That's right. 4:30 Central Daylight Savings, whatever. But I think that what I like about all this is when we put it up on the Facebook group, that it tells you your local time. Like, did it say 5:30 today for you guys?
Yep.
Yeah, so that's what's nice. So whatever it says on the event is going to be accurate for your local time. All right. You guys take care. Thank you.
All right. Thank you.